Hello, and this is what would normally be the first in-class assignment, but since we have no in-class, we will go over it this way through my tutorial. That's why also, if you notice that the PowerPoint that goes along with this, because some people feel the PowerPoint slides are easier to comprehend, or maybe the information is easier laid out on there, you can simply just use this sheet, or you can use the PowerPoint, which starts off by showing in-class exercise. So based on Chapter 1, we talked about the theory data cycle, and we talked about how we could be good producers of research and good consumers of research. And as scientists, we like to dig a little deeper. So I like to start out the first week by going over an example of how we could look at different things, different narratives, different variables, in order to understand how you would put together research. And remember, from the Harlow experiment, we talked about sometimes experiments and psychology research is done not just looking at one hypothesis or one theory, but looking at two competing theories and seeing, like the Harlow experiment, if one theory is better than another theory in trying to explain things. So I use this study and this idea of cheating, which is rampant. We've talked about cheating a lot in academia, especially. And so I'm going to use the topic of cheating to look at how we can look at two different theories and see, based on these studies, if cheating is supported more by one theory than the others, like the contact comfort theory was for Harlow versus the cupboard theory. So a man who is a behavioral economist at Duke University, his name is Dan Ariely, he published a book a few years ago, and the book was for popular audiences called The Honest Truth About Dishonesty. Some of the research from his book was summarized recently in the Wall Street Journal. And by the way, this is a subtle way of also dealing with the fact that very far down the line, although it may come up faster than you think, is that the final paper that we're going to base our experiments on also has to do with cheating. So I'm not trying to tell you guys that this is not a subtle way of me saying don't cheat, especially in this class, but don't cheat in this class. Sorry, not sorry. So some of his research from his book was summarized recently in the Wall Street Journal. Dr. Ariely and his colleagues have concluded from their research that almost everybody has the capacity to cheat and lie. Now, does this mean that everybody cheats and lies a lot? No, but everybody does it at least a little. When we drive a few miles over the speed limit, we're cheating a little bit. If you ever jaywalk or cross before the light turns green, you're cheating a little bit. Cutting corners on certain things, right? We're not talking about cheating in massive proportions, but everybody seems to have the capacity to lie at least a little bit. Bend the rules instead of break them is how it's referred to sometimes. So their research, Ariely and colleagues, investigates the situational forces, the environment, what types of things that make cheating either more likely or less likely. But we ask the question, how do you study cheating in a laboratory? How can you make a fake scenario where cheating is possible? Well, remember that in Chapter 1, we talked about this idea of very specifically defining your variables or how you measure them. In Chapter 3, we're going to talk about this as an operational definition, or operationalizing it. So, cheating, how do we operationalize it? Ariely and his colleagues have creatively operationalized or defined cheating by using a simple math test technique. You guys may have seen matrices in math classes before, or maybe you haven't. So let's take a look at these matrices down below here and basically what you're supposed to do with them. In green, it states, test subjects, usually college students, are given a sheet of paper containing a series of 20 different matrices. So each one of these 3 by 4, so there's 12 numbers in each matrix, and on the paper there's up to 20 of them. And they're told to find in each of the matrices 2 numbers that add up to 10. So as quickly as you can, you need to find the numbers that add up to 10. Now, because I'm very familiar with this, it's very easy for me to look at these numbers and point out that 4.81 and 5.19 here and here are going to add up to 10. Once I find those 2 numbers, boom, let's check this one off. I've solved it. Let's go to the next one over here. So they have 5 minutes to solve as many of these matrices as possible, with, of course, the max being solving all 20 in 5 minutes. And they get paid based on how many they solve correctly. So the more you solve, the more money that you get. When we want to make it possible, okay, how do we make it possible for them to cheat? When we want to make it possible for subjects to cheat on the matrix task, we introduce them to what we call the Schroeder condition. In this case, the subjects are told to count their correct answers on their own, then put their worksheets, their evidence, through a paper shredder at the back of the room. At this point, they're on the honor system. They then come up and tell us how many matrices they solved correctly, and they get paid accordingly. So if we were running a control group, you would solve the matrices, bring them up, show the person how many matrices you solved, and get your money. In the experimental group called the Schroeder condition, you would count, and this is on the honor system, count how many you solved correctly, shred the evidence, and then come up and using your honor, right, taking your word for it, you tell us how many times or how many you solved correct. In this case, it can encourage, or at least allow for students to cheat. So the question is, was the amount of cheating more, less, or the same as the people in the control condition? So here we see participants in Dr. Ariely's studies received a sheet like this. They were asked to find the 2 numbers in each 3 by 3 matrix that add up to 10, or in this case 3 by 4 matrix. Most people reported solving about 4 matrices. So in the control condition, even though there were 20 available, within the 5-minute limit, they seemed to get on average about 4 of the matrices solved in that 5-minute period. What happened to that number when they reported solving if they were allowed to shred the test and after reporting it? So this is where I would ask you guys, do you think that the number was about the same as 4? Was it a lot higher than 4? Was it a little higher than 4? Was it lower than 4? So you can keep that guess to yourself, but maybe you have an idea of where you think it was. So 4 was the number we found in the control group. In the control condition, it turns out most people can solve about 4 matrices in 5 minutes, but in the Schroeder condition, something funny happens. Everyone suddenly and miraculously becomes a little smarter. Participants in the Schroeder condition claim to solve an average of 6 matrices. Now, this is not double, it's not 8, it's not 10. Remember, there were up to 20 of them, but only 2 more than in the control condition. So this overall increase is not resulting from a few people who claim to solve a lot more, but from a lot of people who claim to cheat just a little bit. So this is very interesting. And again, because you can't answer me, in class I would ask the question, why do you think that the cheating is only a little bit? Why do you think it's only an average of 2 more solved instead of 4 more, which doubles it, 6 more, 10 more? Because the more you solve, the more money you get. Well, think about that for a second before we get to this. So, like most programmatic research, Ariely's is theory-driven. So we can again pit one theory against another and see if one is better than the other to explain this phenomenon. Specifically, Their theory, Ariely and his colleagues, their theory states that people are motivated to be able to rationalize cheating to themselves. In this case, they try to balance the gains of cheating against their own self-respect. Importantly, this theory also states what is not happening. People are not driven to cheat simply because they compute how much they're going to gain and lose from cheating. This would be called the gain-loss theory. They don't rationally think about how much money they're going to get and how likely it is that they're going to get caught. Instead, you can embellish things a little bit. If you got a 90 on your exam and you told your parents or your friends that you got a 92 or a 93, then you can say, it's in the ballpark. You can rationalize this sort of behavior. You're not really lying. You're just kind of stretching the truth. It's only a couple of points higher than you actually earned on that exam, but it still makes it seem a little better for you, right? So we have two theories here. We have the rationalization theory that says that people are motivated to rationalize cheating because a little bit of cheating is okay for us to rationalize, but a lot of cheating doesn't sit so well with us. The other theory is gain-loss. If you have more to gain, you're likely to cheat more. If there's not much to gain, then you really don't cheat all that much. So let's read this description of one of their studies and see how their data supports this idea of rationalization theory and doesn't support gain-loss theory, much like Harlow and the contact comfort theory, as opposed to the cupboard theory with the wire monkey that did not have the terry cloth and just had the food for the baby monkey. I would hope by now you've watched that video. So let's do another situation, another description, another study, a variation of the original one. So the first study has the regular condition control where they just solve the matrices and come and show how many they solved and collect their money. And the experimental group had the paper shredder, so they were on the honor system with the paper shredder. In this new situation, a new version of this experiment, they asked the question, Ariely and company asked the question, would putting more money on the line make people cheat more? So they tried varying the amount that was paid for each solved matrix. So we don't know how much they paid for each one. Maybe it was $1 per matrix solved. But would more money cause more cheating? Well, according to gain-loss theory, right, what would we see? If we went from 50 cents per correct answer all the way to $10 per correct answer, that's a huge difference. So if you got 4 on average correct, like the control group, for 50 cents each, you'd end up with $2. If you got 4 correct for $10 each, you'd end up with $40. Or in this case, if we talked about the cheating condition of the shredder where they said 6, you'd get $60 as opposed to $40. But what they found was more money did not lead to more cheating. In fact, the amount of cheating was actually slightly lower when they promised the participants the highest amount for each correct answer. Why do you think this is? Again, I'll answer, because I'm the only one talking. I suspect that at $10 per matrix, the more you cheat, the more money that you are scamming them out of, it's harder for you to rationalize and still feel good about your own sense of integrity. If the gain-loss theory was the one that worked in this situation, right? If that was the winner in theory versus theory, then what we would see is the more money you made, the more you would cheat because the more money you had a chance to make. At 50 cents, it would be reasonable not to cheat so much because you're not really making a heck of a lot of money. The difference is between $2 and $3. In $10 increments, you go from $40 to $60. That's a pretty big difference. So in gain-loss theory, right, question part A says, how does this result support rationalization theory rather than rational gain-loss theory? Again, the higher the gain, the more cheating according to that theory, because you stand to make more money. In this case, what we saw was the opposite of that. The more money that was offered, the less cheating we found. So this supports our rationalization theory more than the gain-loss theory. And this is because it's harder to rationalize that amount of money more than it would be at 50 cents a pop instead of $10. Think if they said $50 per or $20 per correct answer, right? The higher it goes, the less you can rationalize it to yourself. So when you compete theory versus theory, rationalization theory here makes a lot of sense, and gain-loss theory does not. So for each of the following scenarios, I want you to tell me, you're going to have A, B, and C. A is how does this result support rationalization theory and not rational gain-loss theory? And then I want you to tell me B and C. So for B, each example, I want you to identify what's called the manipulated variable and the measured variable. And although this is sort of a preview for Chapter 3, because we're going to go over that again, you should have some idea, at least from Psych 1, about what is the manipulated variable and the measured variable and how we differentiate them. The manipulated variable is also called the independent variable. And the reason we call it the manipulated variable is because it is the variable that the researchers manipulate, which means they put people into groups. The measured variable is called the dependent variable or outcome variable, and that's always the number that is associated with this study. So an easy way, by the way, this answer will be almost the same for all three of these scenarios. The independent variable or manipulated variable would be what groups people are put in according to their scenario. If I go back to my example that I used of the idea of cheating and not cheating, but studying versus not studying, as I used in chapters 1 and 2 lectures, the independent or manipulated variable would be the amount of cheating. So I put people, half the class, into two groups. One half of the class got 0 hours of studying. That was my control group, no manipulation. And my experimental group was the one that studied, according to the Carnegie unit, 6 hours a week. So for my experiment that we went over in chapters 1 and 2, the manipulated variable would be the amount of time studying. 0 versus 6 hours. The measured variable is my outcome variable. So what am I measuring in that example? What am I measuring in that experiment? What is my thing that I'm comparing? What number am I getting from this experiment? And if you think about it, everybody's taking an exam, so what number do we take from that exam that we're averaging? That is the person's score on the exam. That's the number that is my measured variable. So for my example, the manipulated variable is the amount of time studying, in my case 0 versus 6 hours. The measured variable is the exam score, whatever score you get on your exam. So for this one, we ask, would putting money on the line make people cheat more? So we have two groups, or more in this case. 50 cents, $1, $5, $10. It could be 4 groups, or just based on the information you have here, we have at least 50 cents and $10. So in this case, the manipulated variable would be cheating condition, or in this case, it would be amount of money per correct answer, 50 cents and $10. Or you could make it 50 cents, $1, $5, $10. That doesn't matter. So for B, in each one, I want you to tell me what is the manipulated variable and what's the measured variable. The measured variable should be the same, spoiler alert, makes this real easy for you, it should be the same for each of these examples. The only thing that may change is your manipulated variable. So the measured variable for this one is, what are we measuring? The number of answers that they claim to get correct, or the number of matrices they claim to solve. So it would be the number of solved matrices, or at least that they reported, right? So the manipulated variable for the first one would be control condition versus shredder, right? So you could call it cheating condition, control versus shredder. In this one, it would be amount of money for each one, right? And your measured variable for both would be the number of matrices claimed to be solved. C says what causal statement can each study make? So what kind of conclusion can we make if this is based on rationalization theory? So for this one, what we see is varying the amount of money. The more money that was given for each solved matrix, the less that they cheated, or more money did not mean more cheating, which supports rationalization theory, right? That's our causal statement. So here's example 1, 2, and 3. And just to show you guys, because I like it in both PowerPoint and using this for the assignment, here we see rationalization is the, just so I give you definitions, rationalization theory is the cognitive distortion of facts to make an event or an impulse less threatening. We do it often on a fairly conscious level when we provide ourselves with excuses. I ate 6 Hot Pockets at that party the other night because I was just trying to be social with people, and I just went for it, and I was really social and ate a lot of Hot Pockets. Not for any other reason. Gain-loss says that people make their decisions based on the potential value of their losses and gains, kind of like betting on sports or gambling, rather than looking at the final outcome. If they can make more, then they are more willing to do that in order to make more money. If it's not worth it, then they don't do it as much. But what we saw was the opposite. This is why, at least for those first 2 examples, we have rationalization theory supporting both of them rather than gain-loss. So here's number 1. Would putting more money on the line make people cheat more? This was the second example. Here I can show you how do the results support rationalization theory rather than gain-loss. And here I have the little theory data cycle. Number 2, 3, 4, and 5. So here is another example that actually wasn't in this original paper. Would the higher probability of getting caught cause people to cheat less? So in this case, Ariely's group tried different conditions for the experiment. Oh, sorry, this is the shredder condition. My fault. They're just in opposite order on the slides. So in which people shredded their answers. And again, how do these results support rationalization theory? Again, less of a chance of getting caught cheating if they can't actually see your assignment. But again, people don't cheat a lot. They only cheat a little bit. If you had a lot more to gain, why not just say you solved 10, 12, all 20 of them in 5 minutes? Because there's no way for them to prove it. Because people can't justify that. But if they only cheat a little more, that's justifiable to them. Like making little excuses for why you ate that second dinner. I don't know why I'm using food as an example. There's no reason for that. Or why you snuck that extra glass of wine. How's that? So here are the 3 ones that I want you to do. And again, I would like you to use this format of A, B, and C. So for each one of those, you can number them 1 through 3, or you can just say first, second, third. You can call it 3, 4, 5, as long as I know what they are. I want how this result supports rationalization theory rather than gain-loss. I want to know what's the manipulated variable and the measured. And I want to know the causal statement that each study can make. And I'm going to try and prompt you a little bit as I read through the examples. But I want you to come to these and write them on your own. So number 3 says, one thing that increased cheating in our experiments was making the prospect of a monetary payoff more distant. So instead of getting paid right away in psychological terms, instead of getting paid right away, you'd get a token. Which could be then used to later be exchanged for money. So you're not getting money right away. It's almost like getting a certificate or a token, right? A coin that can be used to turn in for money later. So in one variation of the matrix task, people did the normal control group, right? And in the other, they tempted students to cheat for tokens, which would immediately be traded in for cash, but not in front of them. It's like they would get the token, and then they'd have to go trade it in down the hall in order to get cash. So they weren't receiving cash in their hand in the room. They were receiving a token and then cashing it in later. Subjects in the token condition cheated twice as much as those lying directly for money. So I ask you, how do these results support rationalization theory rather than gain-loss? So already in this one, as opposed to the other two, what we find is that cheating was more than the first two. Why do you think this is? Again, in gain-loss theory, maybe you would think that they had more to gain, but in this case, why would we say that it's rationalization theory? Why does this change your rationalization if you're not actually getting the money in that room, but you're getting it later on and exchanging it for something else? In Psych 1, we talk about something called primary and secondary reinforcers when we go over learning, right? There may be a little bit of a difference between getting money, right? Or getting food, like as a child, getting chocolate, M&Ms, for doing something like potty training, as opposed to getting like a star or tokens, and then on a chart, when you get to 5 or 10, then you get a prize, right? So what does that have to do with rationalization as opposed to gain-loss theory? In here, we had a control group of regular matrices, and in this one, we had making the payoff more distant. So what is the manipulated variable here? You let me know. Obviously, what's the measured variable? I'm going to tell you because it's what it is for all of the examples. It's the number of matrices they claim to solve, or number of matrices solved. The next one says, number 4 on this one, which would be number, I think, 2 down here, example 2. So example 2, number 4, whatever, you can number them however you want. Another thing that boosted cheating was having another student in the room who was clearly cheating. In this version of the matrix test, we had an acting student named David get up about a minute into the experiment. The participants in the study, of course, didn't know that he was an actor and thought he was just another participant, and implausibly claim that he had solved all of the matrices. That's right, all 20 of them. Watching this mini Madoff clearly cheat and waltz away with a wad of cash in his hand and didn't get caught, the remaining students claimed they solved, once again, double the number of matrices as the control group. So again, if the control group said they got 4 on average, in this version, all the others said that they got about 8 correct. Cheating, it seems, is infectious. So in this case, he clearly got away with saying 20 and got all of his money for claiming he did perfect in 5 minutes. And yet, we still don't see other people even come close to that. The others, on average, didn't say 12, 18, 15. It was 8. That's double what the control group got, but it's still not nearly as much as David got. So, does this support gain-loss theory or rationalization theory? Yep, sounds right that it also supports rationalization theory. Your question to answer is why? Why do you think this supports rationalization theory rather than gain-loss? What's your manipulated variable? We already know what our control group is, right, in this cheating condition. So you would say regular matrix solving versus what? What's your manipulated variable? And of course, our measured variable, number of matrices claimed to be solved. And so for C, in experiment 1, and this one, example 2, or number 4, we ask, what's the causal theory? So A and C kind of have similarity to one another. What is the causal statement? People cheat double the control group, but a lot less than David because why? That's what I want you to tell me. And finally, in the last one, We took a group of 450 participants, split them into two groups, so if you don't want to do the math, 225 each, and we set them loose on the usual matrix task. This time there's no control group of just regular, but look at how they split it up. We asked half of them to recall the 10 Commandments, and then the other half to just recall 10 books that they had read in high school. Among the group who recalled 10 books before going in the matrix task, or after, actually, we saw the typical widespread but moderate cheating, somewhere in the 6 to 8 range. However, in the group that was asked to recall the 10 Commandments, we observed no cheating whatsoever. That's interesting. What does the 10 Commandments have to do with not cheating, and 10 books in high school have to do with some cheating? How do these results support rationalization theory rather than gain-loss theory? It seems in both of these there may be reason to cheat in both, and yet in one group there wasn't cheating. Why would reciting the 10 Commandments from the Bible make people less likely to cheat? How do you rationalize that? That's what I want for A for this last example, example 3 or number 5. Looking at this, what was the manipulated variable? I will give you a hint that it has to do with 10 and 10. So what were the groups they were put into? Of course, the measured variable was the amount that they claimed to have solved. And then finally, what is based on this rationalization theory that you came up with, what causal claim can we make? What is the moral of the story, shall we say, based on this one? People were less likely to cheat because, and that's where you solve this. So for those 3 examples, or numbers 3, 4, and 5 on this PowerPoint, I want you to upload, and you can just simply copy these and then write the answers underneath them and upload that to the Canvas page. This, along with the Finding Research articles, is due by the end of week 1, which is Sunday, September 6th. So please get it in on time, and I have office hours every day at 2 o'clock, so you can find me, email me, get a hold of me, and we will do this. This is worth 5 points like the original. And until next week or next time, if you want to jump ahead, you'll hear me a little more. I will talk to you soon.